Hey, pre-calc. Here we go with day 56 Ed Puzzle. Okay, so this is day 56 Ed Puzzle, and we're going to talk about ellipses. Okay, so I want you guys to know that I already recorded this once, and it was so long that I'm recording it again, trying to get this short for you. So know how much we care for you guys. So also know there's a lot going on here. So we've got this big graph that shows you the structure of ellipses. You can notice that different from circles, now we have like two fractions. These ellipses have denominators, a squared, b squared. And this is what we call a horizontal. Let's write the word horizontal ellipse. We're going to find out why it's horizontal. It's horizontal because the larger number is under the X. So that makes it a horizontal ellipse. This column is a vertical ellipse. What makes it vertical? The larger number is under the Y, which makes it a kind of a vertical ellipse. Like this is the longer side. So that's what we know. Now, one thing you want to know about ellipses, A is always greater than B for ellipses. Okay. Now, before I talk about everything that's going on here, you see this wonderful picture. I think it would be easier for me to take just two ellipses and just go through it and show you very quickly where the A, the B, the C come from. Okay. We need to know A, B, and C. So you have an ellipse. You have a center. Actually, you've got a couple letters. You've got H and K. You need to know how to graph. And then you've got A and B and C. Okay, so here's what A is. A is the distance from the center to the side, the longest side. That length is A. And these right here are called vertices. They're the main vertices. These here on the shorter side are called co-vertices, and this length from the center to the side with the co-vertice is a length B. Okay, that's pretty easy. Now, there is a little complex feature with ellipses that includes a foci, okay? And the foci actually creates the ellipse. So I'm just going to, we'll worry about too much more about that later, but there's a foci, right? That's one foci and there are two foci. And I'll just say right now that the farther away the foci are from the center, then the longer, thinner the ellipse is. The closer these foci get to the center, the fatter the ellipse is, okay? So that's it for now. Now, this distance from the center to the foci, it'll be the same here and here, right? A is the same here and here, B is the same here and here. This distance is C, okay? So there is a very important formula we have to know for ellipses. Let's put it over here on our main page, right? And here's the formula. The formula is A squared equals B squared plus C squared. Box that in and just, we're going to have to keep that handy. Either we'll get A and B and we'll have to find C, or we'll be given C and B and we'll have to find A. Okay, we need this equation. And it's true for all ellipses. Okay, so when we have all these letters, we can put together the standard equation, the standard form equation. Now, the standard form equation for a horizontal ellipse is x minus h squared over, it's horizontal, so the larger side, A, goes here, plus y minus k squared, where, remember, this center point is your hk, right? And in this case, h is 3, right? 3, and y is 2. So then y minus k squared, and because the shorter side goes here, b squared, ellipses always equal 1. Okay? So to do the equation, I don't need C. But sometimes to figure out what A or B are, I need C. And sometimes I'm asked, what is C? So we'll talk about that more later. Now, let's look at this particular graph and write the standard form for this equation. It's going to be x minus h. Well, this center is 3, 2. Okay, so looking at this, H is 3, K is 2. A, let's see, what is A? A is the distance from 3 to the vertices. It's going to be the same. It's going to be 6. What is B? The distance from the center to the side here, that's a distance 2 to 4, 2. I don't need to know C for this equation, so I'm just going to hold on that for a moment. X minus 3, there's my H, squared, over A is 6. So underneath in my equation, I take 6 and square it, 36. Plus Y minus, go get your K value, to the center of the circle, over B, this is 2 squared, 4 equals 1. Okay, so if you have H, K, A, and B, you can write the equation, standard form equation for an ellipse. Let's do one that is vertical. Okay, so let's label A, H, K, A, and B. So we know HK is the center, right? And that for this ellipse is negative 2, 2. Negative 2, 2, right? HK. Now A, the distance here, because this is a vertical ellipse, this is my A distance, 2 to 5. A is 3. B is the distance from the center to the shorter side of the ellipse, and that's just between negative 2 and negative 3. B is 1. These are distances. They're always positive. Okay? Notice that ellipses are two fractions added together. Okay? So now we have everything we need to write the equation. So let's do it. So we have X minus H. X minus a negative 2 gives me a plus 2 squared over, now, because it's a vertical ellipse, I don't put A here because the A goes under, let's just leave it blank. The larger, this length, A squared, goes under the Y, because Y minus 2 squared over 3 squared. The larger number goes there for a vertical ellipse. But the smaller number, B squared, goes here, equals 1. Okay? So that would be the equation for a vertical ellipse. Okay, so let's keep going. So this you have to refer to, for the future. Everything we talked about is right there. Let's do some problems. Whoops, let's leave that for now. Okay. Let's go through this. So you're given an equation. You want to identify the center A, B, the foci, and the vertices, their actual coordinates. So graphing helps us when we're trying to identify things like these. So the center is X minus the center is 2. Look at that, negative 1, right? Now, look at where is the larger number? Under the Y, so this is a vertical. This is a vertical ellipse. I look at this, and this has the larger number under the X, so this would be a horizontal ellipse. So that's really this is going to be a vertical ellipse. So let's graph the center. 2, negative 1. There's my center. Now, A is going to be the larger, this is A squared, so A itself will be 4. This is B squared, so B is 3. Foci, let's worry about that last. Let's look at the vertices. Well, let's graph it. The easiest way to find where the vertices are is to graph A and B from the center. So I look at the vertices. Now they're going to be up and down because this is vertical. So I take the center and I go up 4. 1, 2, 3, 4. There it is. 2, 3, okay, is one of my vertices. 2, 3. Then I go down 4. 1, 2, 3, 4. So 2, negative 5, right? It's just this point right here. 2, negative 5 is the other vertice. Okay, these are vertices. These are the main ends of the ellipse. Now, to find the co-vertice, I go left and right 3. 1, 2, 3. That's a co-vertice. 1, 2, 3. That is a co-vertice. So let's write these co-vertices down. Well, I just look at them. Negative 2, negative 1. -2, -1, and then 5, go over 5, -1, 5, -1. Those are my co-vertices. Okay, so the question, and then I could graph. My point today is to graph so I can connect my vertice, co-vertice around the center, but I need to find these foci. Okay, there I need the letter C. So let's go back to our equation. We know that a squared equals equals b squared plus c squared, b squared plus c squared. So a squared is 16 equals b squared, 9 plus c squared. All right, solve for c squared. Subtract the 9 and you get 7 equals c squared. C itself equals the square root of 7. All right, so let's just think about picturing this. So I might use my calculator to give me, because I have to graph it, how far away what is the distance of the square root of 7? Well, I don't know. Let's do it. Second square root of 7, 2.6, okay? It's approximately 2.6. So when you think about it, you go to the center and you add to the y value, you go up 2.6. There's a foci. Then you go back to the center and you go down 2.6. There is a foci, right? You've got a foci and a foci. Now, how do I write them as coordinate values? Now, listen carefully. This is probably one of the hardest things about ellipses. You go to the center. Your center is 2, -1. Because it's a vertical ellipse, you're going to add your C value to the Y vertical. So this is what this looks like. Okay, you write 2, -1, and then you subtract square root of 7. Okay, your next point, go to the center. 2, -1 plus square root of 7. So you see what's happened here. I have my center and I've added the C value to the Y, right? I went to X and then I went to the center and I added C. I went to the center, X, then I went to the Y value and I subtracted the C value. That's how we write those. Okay, I know it's a lot. So you really, really need to stop the tape and try this one on your own and see what questions you have. Stop the tape. Okay, so check yourself. How did you do? Okay, stop the tape for a moment and see what you didn't, if you got this correct, and ask any questions. You see what I did is I went to the center, -1, 3, but instead of adding it to the Y value, because it's a horizontal ellipse, I added the C value to the X. Okay? All right, let's keep going. And remember, you can stop the tape at any time and slow down. Okay, so here we've got 4 situations where we're given various details about the ellipse and we're asked to write the equation for the ellipse. Okay, so let's do this one together. Write the standard form of the equation, right? And that's back to these, it's on the front side, these standard forms, right? Where the a squared is under the largest, a squared is largest, and if it's either under the x or it's under the y for this one. Okay, so let's figure this out. So first you're figuring out horizontal or vertical. Let's just graph this. I can't tell until I graph it. So the foci are at 2, 4. All right, well, let's plot the foci. 2, 4, you might write an F there. And then you write 2, 2. Okay, well, one thing, those are foci. And then let's do vertices. Vertices, 2, 0, 2, 6. Okay, the fact that these are vertices tells you, and that they're lined up, on this line parallel to the y-axis, tells you that this is a vertical ellipse. Vertical ellipse. So the larger number is going to be under the y. The next thing you can easily discern is the center is right here in the middle. Okay, so I can write up here, the center must be at 2, 3. 2, 3, very important because that is h and k. Now I've got to find a and b in order to write my equation. So I look at the graph and I have a, the distance from the center to the vertice. Well, that's 3 to 0. A is 3. B, I don't have covertices. I don't have B, but I do have C. C is the distance from the center to the foci is 1. I need to find B before I can write an equation. So I go back to my equation that I know, a squared equals b squared plus c squared. Fill in what you have. 9 equals b squared, which I don't have, plus 1 squared, 1. Solve for b squared. B squared equals 8. B equals the square root of 8. The square root of 8. And I can, on my calculator, what's the square root of 8? 2.8, right? Approximately 2.8. So I can look and see where approximately where it is. I go to the center and I go 2.8. Go to the center and go left, 2.8. Okay? And there is all you don't have to, when you're writing the equation, you don't need to, you're just going to use b squared, right? So you know that b is the square root of 8. What's b squared? 8. Okay, so let's draw in our graph. We're graphing. Now we can pull our equation together, right? X minus h2 squared. Okay, let's just leave the denominators for a minute. Y minus k squared over something equals 1. Now, we know we have a squared and b squared. A squared this is a vertical ellipse. So the larger square, a is going to go under the y. 3 squared is 9. B squared is 8. Okay, and there I have pulled together my equation for an ellipse. Okay, now I want you to stop the tape, do this graph, do the exact same thing we did. You got to find A and B and X, H and K. That's what you need to write an equation. And then you're going to instead of being given descriptions, you're given a picture, but you're given the center, which gives you H and K. From the picture, you can find A and B. So you do that. And once you have those 4 things, you can write an equation. Now, for this third one, look what it tells you. Let's interpret this. A vertical major axis. Okay, let's stop. I don't know if we've talked about the word major. So if I'm looking at this, sorry. I'm looking at this graph. The major axis is from here to here, right? It is from 3 to 9. The major axis is the long one, and this is -3, right? So this is going to be 9 plus -3, 12 units long, okay? The major axis is always 2 times A. Well, A here is 6, right? 2 times 6 equals 12, right? We see that with our picture. And then the minor axis is this length from here to here, right? The length of the ellipse on the shorter side. And that's going to be from 4 to 0. That length is 4. And the minor axis is, you guessed it, 2 times b, which is 2 times 2. We see that, right? In this case, it's 4. So major and minor axis. So vertical. Okay, that tells me major axis. That tells me this is a vertical ellipse with a length of 10. So what I know is I have a vertical ellipse and the whole major axis is 10, which tells me immediately what A is, right? Because half of that, this distance, A has to be 5. This is like a puzzle. It's kind of fun. The horizontal minor axis has a length of 2. So the whole minor axis has a length of 2. So the B value is 1, right? So I've just seen that A is 5 and B is 1. The center is -4, 3. So I have H and I have K. So now you have everything you need to pull an equation together. And I'll do this one with you. So vertical. Where's the larger number going to go? Y, under the Y, because this is a vertical ellipse. So I have x minus h, x plus 4 squared, plus, I'm just going to leave my denominators for a minute, y minus k 3 squared over something equals 1. All right, vertical ellipse. Larger goes here. This 5 squared, 25. B squared, 1. Okay, so there we go. That is the correct equation. Okay, so stop the tape. Do these two, okay, and answer any questions. Okay, so you can see the answers to that in class, and hopefully you were able to do that, but I'll show you the answers to that in class. Now what we need to do, okay, is we need to do one more thing with ellipses. We need to be this, when you see the equation like this, right? This is like a squared plus b, ax squared plus bx plus c equals 0, right? That's kind of, we call it standard form, but this is what we call, I'm going to write it down for you, general form. When you see it like this, general form. You see that you have an x squared and a y squared. They're both positive. You got x and y. Oh, wow, it's a mess. Kind of. It feels like, ugh. All right. The standard form is this form. And we like standard form better because it immediately tells us, whether it's vertical or horizontal, what length, what the size of the ellipse is, distance from the center, 5 and 1. Okay, we need to get there from here. That's what we're doing. And the skill we learned last class, which was complete the square, we're going to do it again. Okay, so let's complete the square and write the standard form for this equation. Okay, let me see if I can zoom in a teeny bit. Okay, so group x terms together and then leave a space. So I'm going to group them together. I've got 4x squared. And then my other x term is plus 24x. Leave a space. Write the y term. Plus 25y squared. Then the next y, so you've got this, and you've got this. Now, minus 50y, leave a space, equals, and move all numbers, constants, just to the right of the equal sign. So add 39 to both sides, equals 39. Okay, I have accomplished step 1. Okay, group x terms and y terms and that. Okay, now factor out the GCF for the x terms and the y terms. Okay, GCF for the x terms is 4, so I factor it out. X squared plus 24 divided by 4, 6x. Leave a space, write the end parentheses. Now let's factor out the GCF here. Plus the GCF for the y's is 25. I factor it out and I get y squared minus 2y, leave a space, equals 39. Step 2. Okay, accomplished. That's what I need to do for step 2. Okay, let's look at step 3. I'm going to take a different color. Complete the square for both variables. When you add c to the right, so you're going to find c for this trinomial. You're just going to find it. Then once you found it, in order to keep these equations balanced, you're going to multiply 4 times that before you add it to the right-hand side. You're going to multiply 25 times whatever c is to the right-hand side. Okay? So that's what it's saying here. So let's find c. Now I'm going to move this paper up here, and you might want to use some extra scrap paper to find c. So now I'm just looking at this, and I know that c is b over 2 squared. So 6 over 2 squared, 6 over 2, 3 squared, 9. Now, you might want to circle this number because this number here, b over 2, is what is my binomial squared. Because what am I doing? I'm trying to turn this trinomial into a binomial squared, right? A binomial squared. Okay, so circle that number because you're going to need it. Okay, so, but you put c here, plus 9. That's what you were doing. You were finding c. Now, before you add it to the right-hand side, you have to say, all right, well, it's in parentheses, 4 times 9, add 36. Okay, now let's do this one. We're just put your finger over there. We're just finding c. C is b over 2, right? B over 2 squared. Negative 4 squared, well, that is 16. Now, circle this because this is going to be your binomial in your binomial, a negative 4. Okay, now put 16 here plus 16, and you're going to multiply 25 times 16 and add it to the other side. So you got a calculator. 25 times 16 is 400. So I'm going to add 400 to the other side of the equation. Okay, so let's add these up. 400 plus 39 plus 36 is 475. Why is that not looking familiar to me? Oh, what did I do? I don't know where I got this 4 from. I'm losing my mind. Forgive me. This is a 1. Negative 2 over 2 is 1. 1 squared is 1. All right, I'm just adding 1. Wow, I don't even know what I did there. 25 times 1. This is not 400, right? Multiply 25 times 1 and add 25 to the other side. I'm going to add all of these together and get 36 plus 25 plus 39, okay? Add all those together, okay? You are going to get on your right-hand side 100, okay? Now let's rewrite both of these trinomials as their binomial squared, okay? So this is going to be 4 times x plus b over 2, x plus 3 squared. Let's do the next one. Plus 25 times y plus b over 2. Y, b over 2 is negative 1 squared. Okay, a lot going on here. So now you've got this purple equation, but you need the right-hand side to be 1, right? Because this is an ellipse. So you divide everything by 100 so that your right-hand side is 1. Okay, so now here we go. When we reduce this fraction, right, this is going to reduce to 1/25. This 25 over 100 will reduce to 1/4. Okay, this over here, 100 over 100, will reduce to 1. So now I'm ready to write my final equation. And here it is. I'm going to try it in a different color. So it's a little bit messy here. You've got x plus 3 squared over 25 plus y minus 1 squared over 4 equals 1. And this is, okay, my horizontal ellipse with an a value of 5, a b value of 4, and a center at negative 3, 1. Okay, so let's quick review. You split up the x's and the y's. You factor out the GCF, okay, in both terms, for both variables. Then you look at the trinomial, you find c, then you multiply by the GCF and add. You find c here, then you multiply by the GCF and add. Then you get 100 here, and you just take this equation, you divide by whatever's on the right-hand side, and it simplifies down to an ellipse. All right, it's a lot. Stop the tape. do the problem on the bottom of the page. See what you understand and what you don't. My advice is write down a question and ask it in class tomorrow. All right. So I'm going to take away this, and how did you do? Okay. Did you get to this equation and realize that it's a vertical ellipse with the center at -4, 1? All right. We'll get to practice in class tomorrow. Good job, and I'll see you tomorrow.